Hello everyone, I am Dr. Alok Agrawal, working as an associate professor in the Department of Mechanical Engineering, Sagar Institute of Research and Technology. In this video, I will be discussing about the important topic of course ME603 Turbo Machinery, that is Unit 4, and I will be discussing classification of compressor. First of all, let us see what is the function of compression. What compressor do? Compressor generally takes a definite quantity of fluid, which is generally gas, and deliver it to a very high pressure. So what is the function of compressor? Its function is to increase the pressure of the fluid. How it works? If you are talking about air compressor, it takes air, compresses it by the input of work, and that high pressure air it delivers or it gives to a vessel where that high pressure air is stored in, and that vessel is called storage vessel. And from there, as per the requirement, we can take that high pressure air. This high pressure air is supplied to a pipeline through a pipeline wherever it is required. So how it works means, to drive a compressor, we need a prime mover. That prime mover, what it does, it takes heat and convert that heat into a work. Generally, it has been observed that a part of heat is converted into work, and that work is utilized to drive the compressor, and most of the heat is getting rejected into the atmosphere. When this compressor takes heat as a work from that prime mover, it takes low pressure air, compress it, and supply it to a storage vessel, that high pressure air. That high pressure air is supplied to the storage vessel, is getting stored there, and whenever it is required, we can use it to certain applications. Okay, and in that process, there will be a generation of heat, because whenever we compress air, there will be a generation of heat. That heat will be rejected from the compressor with the help of coolant or radiation. Otherwise, what will happen? Because of heat, we are compressing the air, but as the temperature of the air increases, it tries to expand, and which decreases its density again. So the compression level will be nullified. So it is very much necessary that the compressed air should be cooled so that the pressure will be maintained. So this is the overall layer diagram of compressor, how the air, low pressure air is getting converted into high pressure air. Now let us move to its classification. So generally compressor is classified as reciprocating compressor or rotary compressor. In reciprocating compressor, what is happening? Here the air is getting compressed with the help of piston, where the piston reciprocates and compresses the air. This reciprocating compressor can be single acting or double acting, depending upon if the air is getting compressed on one side of the piston, we call it as a single acting compressor, and if it is compressed in both sides of the piston, we call it as a double acting compressor. Again, this compressor, if we are uh, mounting it in the form of one after another, we call it as a multi-stage compressor. Otherwise, if we are using single compressor, we call it as a single stage compressor. In case of rotary compressor, there will be a primary element which is a rotating element. The function of the rotating element, what is it? To compress the air. There will be a transfer of energy between a rotating element and a flowing fluid. We called it as a rotary compressor. The function of both the compressor are compress the air and deliver it at high pressure. So in this unit, that is unit 4, we will be dealing on rotary compressor. Reciprocating compressor is also very important part, but here we are dealing, as the subject is turbo machine, where one element should be a rotating element. So we need to discuss here only about rotary compressor. So let us move to the rotary compressor and its classification. So this rotary compressor is again classified in two different levels. First is displacement compressor, which is also called positive displacement compressor, and another one is steady flow compressor, which is called non-positive displacement compressor. So both are having certain compressor in their category. That is, in displacement compressor, we have roots compressor, sliding vane compressor, Dyson compressor, and screw compressor. Whereas in steady flow compressor or non-positive displacement compressor, we have two types of compressor, that is centrifugal compressor and axial flow compressor. What is happening here? The compressor where the compression occur by transfer of kinetic energy from a rotor. We called it a steady flow compressor. So there should be a rotor. We called it as a steady flow compressor. And if there is something else where the component is getting displaced from one place to another place, we called it as a displacement compressor. But where there will be a rotating element and it rotates about its own axis, we called it as a steady flow compressor, where the transfer of kinetic energy is taking place on rotor. So again, in rotary compressor also, we need to discuss in this unit about steady flow compressor only, and we are not discussing about displacement compressor. So let us again move to steady flow compressor. So what is a steady flow compressor? See, we have seen that there are two type of compressor, that is centrifugal compressor and axial flow compressor. We will discuss both type of compressor in detail in coming videos. Here, what we are discussing, what are the main difference between the centrifugal compressor and the axial flow compressor. So for low pressure ratio means if you want to increase pressure 4 times, we use generally centrifugal compressor, which is lighter, and if we need high compression ratio, we need to use axial flow compressor. Okay. Now this for high pressure ratio, axial flow compressor is generally more efficient. That's why we are using it. Whereas sometimes we can also uh, put that centrifugal compressor in series to get a desired compression ratio of more than 4 is to 1. But if we require compression ratio up to 4 is to 1, generally we use centrifugal compressor only. If we need high compression ratio, either we need to uh, put the centrifugal compressor in series, or we can use axial flow compressor because it has multi-stage compressor inbuilt in it. In aircraft, where high pressure ratio is required, in the marine engine where high compression ratio is required, we use axial flow compressor because it can provide high compression ratio. Where we need to we have restriction of space actually, then in that place we use centrifugal compressor because axial flow compressor are quite long, so it requires a lot of space for mounting, whereas centrifugal compressor is very simple in construction, its weight is also less. So at that kind of places where very high pressure ratio is not required, we generally prefer centrifugal compressor. Okay. One more advantage of centrifugal compressor is there that it has more efficiency as compared to the axial flow compressor. But when there is high pressure ratio is required, we need to use axial flow compression. Now let us move into the advantages and disadvantages of steady flow compressor. So what we are doing, we are comparing the centrifugal compressor and axial flow compressor. In centrifugal compressor, we will see what are the advantage of centrifugal compressor over axial flow compressor, and then we will see what are the disadvantage of centrifugal compressor over axial flow compressor. So let us start with advantage of centrifugal compressor over axial flow compressor. In centrifugal compressor, what is happening? Air will move in a radial direction, whereas in axial flow compression, air will move along the axis of the rotor or the rotating element. So this is the basic difference. So what are the advantage of centrifugal compression? Its length is less because the flow of fluid is in a radial direction, whereas in axial flow direction, it need to be flow along the axis, so its length should be more. Again, in centrifugal compressor, if the atmospheric air is contaminated, there are a lot of dust particles and other things are there, it will not deteriorate the performance of centrifugal compressor, but in case of axial flow compressor, its performance will be reduced. Okay, that's why axial flow compressor are used in a place where the chances of contaminated air is less, like in aircraft, where at a particular when aircraft being at a particular height, there will less chances of getting contaminated air. Further advantage of centrifugal compressor is that it can perform effectively over a large range of or over a wide range of mass flow at any speed. Whereas axial flow compressor, there are restriction of mass flow rate. Another very important advantage of centrifugal compressor is that it is cheaper to produce. The amount required for the construction of centrifugal compressor is comparatively less as compared to the axial flow compressor. Further, the centrifugal compressor, even at low cost, it provides high robustness. Means the robustness of centrifugal compressor is more than axial flow compressor. and it has less prone of icing trouble at high altitude. Means if we move at high altitude, the problem of icing will be less in case of centrifugal compressor than in case of axial flow compressor. So there are multiple advantages of centrifugal compressor over axial flow compressor, but there are certain disadvantages also. Like the frontal area of centrifugal compressor is quite large as compared to axial flow compressor. Apart from that, the efficiency of centrifugal compressor is less as compared to axial flow compressor. Means I am talking about the maximum efficiency. Okay, while running they may be same, but if we talk about the maximum efficiency, then axial flow compressor will deliver higher efficiency as compared to centrifugal compressor. So both compressors are having certain advantages and disadvantages. Depending upon the application, we need to choose which compressor is best for us. When we are talking about high compression ratio, obviously we need to use axial flow compressor because axial flow compressor can have multiple stages in it, and in that case air will be compressed more, like in the compression ratio of 10, 12, or even 50. But in case of centrifugal compressor, if we need to compress the air more, we need to connect the different centrifugal compression compressor in series, which will be costlier. And that's why when low compression ratio is required, that is up to 4:1, we generally use centrifugal compressor because of its cheapness. Mainly cheap, it is cheap and easy to install. So these are about the compressor, how it works. So for compiling the video, I am talking that for working, compressor require a prime mover, where from, because it is power absorbing device, it absorb power and runs, take air or any gas at low pressure and deliver it at high pressure. When the compressed air is coming out of the compressor, it generally need to be stored in a vessel which is which is to be highly robust so that it will contain that high pressure air, and whenever it is required we can take that high pressure air from that vessel. That compressor is further divided into two type of, whether it's reciprocating, rotary. Reciprocating and rotary both are different category of compressor. In reciprocating, the energy transfer took place between the air and the piston, whereas in rotatory there will be a rotating element and there will be air where energy transfer can take place. This rotatory transfer is further classified as positive displacement and non-positive displacement. In positive displacement, what we are doing, we are having a component which displaces from its place, whereas in non-positive displacement, there is a uh, component which rotates, where the air only take centrifugal force or other type of force. Like in in this unit, we need to discuss about the non-positive displacement compressor. In that category, we have centrifugal and axial flow compressor. We have taken the introduction of both the type of compressor. In next video, we'll be discussing the two type of compressor in detail. So in this video, for this video, thank you very much.